Alright, if you're getting ready for your WAEC, JAMB, or NECO chemistry exams, you are in exactly the right place. Today, we're diving into a topic that is pretty much guaranteed to show up on your paper: acids, bases, and salts. Let's break it all down so you're ready to absolutely ace those questions. You know, just think about the sour taste of a lemon. Yep, that's an acid. Or the slippery feel of soap. That's a base. And the salt on your food. You guessed it, that's a salt. These chemicals are literally all around us, and really understanding them is so crucial for scoring high on your exams. So, let's get right into the fundamentals. Okay, let's start at the very beginning, with the core definitions you absolutely have to know. So, what actually makes something an acid or a base? So, the easiest way to think about an acid, it's a proton donor. When you dissolve an acid in water, it releases hydrogen ions, these little H+ particles. A classic example you'll always see is hydrochloric acid, or HCl. As soon as it hits the water, it splits apart, or dissociates, into H+ and chloride ions. That's really it. And now, for the other side of the coin, bases. Well, a base basically does the opposite. It can either accept the hydrogen ion, or, like our example sodium hydroxide, NaOH, it can release a hydroxide ion, that's OH-, into the solution. So, the bottom line is, acids give away H+, while bases either take H+, or give away OH-. So, how can you tell them apart in the lab without testing them, which you should never do? Well, this slide right here. It's your perfect cheat sheet. Acids have that sharp, sour taste, they turn blue litmus paper red, and they react with some metals. Bases, on the other hand, they taste bitter, turn red litmus paper blue, and have that slippery, soapy feel. Seriously, these properties are pure exam gold. Memorize them. Okay, so we know what acids are, we know what bases are, but what happens when you actually mix them together? Well, you get one of the most important reactions in all of chemistry, neutralization. And this is exactly how we get salts. Let's see how it works. I want you to think of it like a little story. First, an acid and a base meet up in a solution. The hero of the acid, the H+ ion, meets the hero of the base, the OH ion. They get together and form neutral water, H2O. Now the big question is, what's left over? Well, in our example, you've got the sodium ion and the chloride ion, just hanging around. So they pair up and form sodium chloride. Yep, regular table salt. It's that simple. Acid plus base gives you salt plus water. Now here's where it gets really interesting. Not all salts are neutral like table salt. You see, if an acid doesn't give away all of its hydrogen ions, you end up with something called an acid salt, and that will make a solution acidic. And on the flip side, if a base has leftover hydroxide ions, you get a basic salt. Some salts even trap water molecules right inside their structure, becoming hydrated salts. It's a whole family of compounds, and you can bet your exams are going to test you on knowing the difference. Speaking of exams, you've got the theory. Now it's time to really put that knowledge to the test with actual past questions. This is where the rubber meets the road. Let's see if these concepts have really sunk in. Okay, here's our first challenge, straight from a real WAEC paper. Take a good look. The question is asking which of these acids can only form normal salts. Go ahead and pause this explainer for a second. Really think it through and pick your answer. We'll solve it together in just a moment. Did you get it? The answer is C, acetic acid. So why is that? Okay, the trick to this question is that little phrase normal salts only. A normal salt happens when all the replaceable hydrogen ions in an acid are replaced. So we are looking for an acid that only has one hydrogen to give away. We call that a monobasic acid. Acetic acid is monobasic. All the others are either dibasic or tribasic, meaning they have 2 or 3 replaceable hydrogens. They can form normal salts, sure, but they can also form acid salts. So the pro tip here is huge. The basicity of an acid is simply the number of replaceable hydrogen atoms it has. Awesome job. ready for another one. This time it's from JAMB. This question is testing your understanding of the nature of the salt you get at the end. So, what happens when a strong acid reacts with a strong base? Pause here, lock in your answer, let's see what you've got. And the correct answer is B, neutral. This question is all about a concept called hydrolysis. That's just a fancy word for whether the salt reacts with water to change the pH. When a strong acid and a strong base go head to head, they are perfectly matched. They cancel each other out completely. The salt that's left, like our good old friend NaCl, doesn't mess with the water, so the pH stays at a perfect 7. And that pro tip there, that's your golden rule. A strong combo is neutral. But if one of them is weak, it's gonna tip the scales. Remember that pattern. Fantastic work on those questions. We've walked through the concepts, we've seen them in action in real exam problems. Now, let's pull it all together into a clear, winning strategy that you can take with you straight into the exam hall. Alright, let's do some rapid-fire tips. Number 1, always, and I mean always, balance your chemical equations before you do any calculations. It's step 1 for a reason. 2, for JAMB, since it's multiple choice, knowing your definitions and properties code is absolutely key. 3, like we just saw, the strength of your acid and base totally changes the final pH, don't you forget it. 4, know your common indicators, like litmus, and what colors they turn. And finally, for WAEC and NECO where you have to show your work, please don't lose easy marks. Always show your units. Okay, I'm going to leave you with one final question to really get you thinking. We know a normal salt, like NaCl, dissolves in water to make a neutral solution, right? But what about an acid salt, like sodium hydrogen sulfate, NaHSO4? I mean, it still has a replaceable hydrogen right in its name, so what do you think happens to the pH of the water when you dissolve that? Chew on that for a bit. Keep practicing, and you are going to master this topic. For more practice questions and solutions, visit examkp.com. Good luck.